Hello! Hey guys, I'm Frank, and today I'm tutoring Vanessa, who's my camera woman today. She's a little camera shy. Vanessa, so Vanessa's in my Orgo 1 summer prep class, and we're gonna get Vanessa super ready for Orgo 1 in the fall. I just went over hybridization and atomic orbitals and 2s, 1s, all that stuff. If you have any questions on that or want to understand why that stuff works and why that becomes Sp3 orbitals, check out this video right now. Okay, here we go. By the way, this is Professor Rubio's notes from BU, so props goes to Professor Rubio. He gets the credit for these notes. So here we go. We're talking about carbon right now, and carbon has 6 electrons. And basically, how I think about orbitals and hybridization is that carbon essentially has 4 main arms. They are the 2s arm, the 2p arms, 1, 2, 3. So 3 and 1 altogether, that's 4 arms. We don't really care about the 1s arm because that's like very inside and it doesn't really participate in reactions. So for the purposes of Orgo, think of carbon as only having 4 arms. The 2s orbital, which is circular, and then the 3 2p orbitals, which we drew on the board actually. So Vanessa, can you show them? Yeah, so ignore the 0 and the 1 stuff. This is the 1s orbital. This is actually the first arm that carbon has. And I call it arm because that's where it can hold on to electrons. So electrons can be held on to in this area, the 2px, which this orbital runs like this, or this arm looks like this. It's an hourglass arm, which is kind of weird. But yeah, 2px, 2py runs along the y-axis. And 2pz, which is where most students get kind of confused, but it is actually going into the board and out of the board. So we/Orgo people show it this way so you can actually see the orbital. Otherwise, it just looks like a circle to you. You can't really see it. All right, so once again, it has 4 main arms, the 2s, 2pz, 2px, 2py. And you can just think of these as like directions, kind of. If you saw like a building, there's the height of the building, the y, the width of the building, x, and the depth of the building, the z. All right, so let's come back to here for a second. So carbon has 6 electrons because carbon's atomic number is 6 protons, 6 electrons, 6 neutrons. Well, so you fill them in like this, 2 in the 1s, 2 in the 2s, you know, there's 2 left, so they go here and here, and the y-axis is stability, more or less. So the question is, why does carbon upgrade 1 electron into this orbital, like this, and then why does it then hybridize to make 4 sp3 orbitals? It's kind of weird, and that might not have made sense to you, but especially because this is more stable, this is less stable if you go up, and this is more stable if you stay down here. Well, first off, let's just talk about this. Why is the p orbitals not as stable as the s orbitals? Hit pause if you need to. So yeah, why is it that the s orbital is more stable or lower in energy? Why is it lower in energy than the p orbitals? Well, Vanessa actually got this right away, which is really awesome. Vanessa said that it's because if you have electrons here flying around, they're farther away from the nucleus, which is in the center. Boom, boom, boom. So, of course, the 1s orbital would be the most stable. Your electrons are held really, really close to the nucleus. And why is the nucleus so important? Well, that's where your protons are, your positive things that are attracting the electrons. If your electrons are way out here, like far away from the nucleus, I mean, they'll get close here, but actually that's why it shrinks. As electrons approach closer, they get closer to the nucleus, and then they get farther away. So if they're out here, they can get pulled away by some other atom's nucleus, or they can just fly away, I guess. Think about it that way. So that is why the 2p orbitals are higher than the 2s, and the 1s is even lower than the 2s orbitals. So let's go over here. Why do atoms upgrade this electron up to here, decreasing stability, but then hybridize? Well, they do this for like they do it for like a split second because it provides an awesome benefit. And that benefit is that it allows you to fuse together or hybridize your 4 arms. Your 2s, your 2px, 2py, 2pz, they all hybridize together. 1, 2, 3, 4 orbitals go in to this machine. Think of like a cranking machine, somewhat, not really. And then you crank out 4 orbitals as well. 1, 2, 3, 4 sp3 orbitals. Why are they called sp3? They are created by 1 s orbital and 3 p orbitals.
What?
Yeah, so that's why it's Sp3. And then I'll just take a quick glimpse into why things are called Sp2 and why things are called Sp. And yeah, here we go. So when you have Sp2 orbitals, that's because only 2 of the p orbitals are hybridizing with 1 of the 2s orbitals. One of the 2s, so it's still 1s going in. I don't mean this, I mean like 1s. So 3 go in, 3 gets pumped out, essentially. Okay, 3 in, 3 gets pumped out. And then for Sp, let's see if you can get that, yeah, right here. For Sp, see, only 1 2p orbital goes in and 1 2s orbital goes into the machine. It's not really a machine, but 2 goes in, 2 gets pumped out. And the benefit is that these are all lower in energy than the p's. Here, same here. These 4 orbitals are all lower in energy than the p's. Now they're not quite at the halfway mark because there's more p orbitals going in, but it's still better than having, you know, really high level p orbitals. So yeah, and then what these Sp3 orbitals actually look like is a combination of your s and the p. So if you look over here, this is a pure p atomic orbital or arm, and this is a hybridized orbital. It has some s characteristic because this lobe is nice and kind of circular rather than hourglass. So yeah, and if you're curious why these guys are not going in for Sp2 or Sp, well, right? Why isn't this guy going in to be hybridized? Why is he staying there? It's usually because you're creating a double bond, and double bonds are created by parallel p orbitals. So you've sacrificed one of your p arms to bond with a p arm on another carbon atom to create a double bond, basically, or a pi bond. If you wanted me to make a video on that, I'll be happy to do that. Let me know. This is Hybridization Made Easy intro. I'm Frank, Orgo Tutor, and yeah, thanks for watching. If you like this video, make sure you like it down there. The Clutch Prep coupon for this period of time is Orgo Made Easy -pen -PEN, and you can get a 20% discount on Clutch. If you don't know who they are, check out my video, Clutch Prep Rocks My Socks. I'll have a link down in the description in the sticker. As always, tell your friends if you like this video, and subscribe to get updated. There's that little bell button you can click. And if you want to help support these videos, you can do so at patreon.com/orgomadeeasy. Sticker is right there, or in the description down below. You can donate as little as $1.50 or $2 a month. So thank you so much, and I'll see you guys in my next video. Bye.